Hey, it's Roger, creator of the Azure Sandbox. Welcome back. In this video, we're going over the documentation for our Linux jump box that was provisioned as part of the Azure Sandbox, otherwise known as Jump Linux 1. So this video replaces a previous video I recorded because I've made several updates to the configuration of Jump Linux 1. So I want to make sure that you all have current information. So let's get started. So if we look at the documentation for the Linux Jumpbox VM, we can see that the configuration information that Terraform uses to provision the Linux Jumpbox is in this file, 04vm jumpboxlinux.tf. So let's pull that up and have a walk through it. So here I am in my client environment in VS Code. I've got a successfully provisioned VNet app configuration. We've just completed the smoke testing for that. And we're going to have a look at the Jumpbox Linux configuration. Let's bump up the font size for those of you who might be vision impaired, as I am. Okay, so this is the Terraform configuration file that we use to provision Jump Linux 1. So let's just go through this. So the first thing that you'll notice is this data resource. And what this is this is a data resource that is created using the Cloud Init utility provider for Terraform. So if we go look at common, you'll see that this particular configuration uses a utility provider called Cloud Init, which HashiCorp publishes. And this makes it really easy to create these configuration files that you use to configure Linux VMs using the popular Cloud Init service. So to create one of these config files, you have to create a data resource. And you can see here that when we create this cloud config, it'll both be gzipped and base64 encoded before it's sent to the machine as user data. So here you see we create that cloud config, we put a bunch of stuff in it, and then down here when we actually provision the VM, this is where it actually gets passed to the VM as user data, okay, or custom data. And then Cloud Init, when it wakes up on that VM, knows where to look for that custom data. Okay, so let's dig into this Cloud Init config file that we're creating. So it's a MIME file, a multi-part archive, and each part here is defined in 3 separate sections, right? So we're stuffing these 3 files into a MIME file, a multi-archive file, which is the same file format that's used to send attachments via email for your information. And we're going to send that MIME file down as custom data, and it'll get picked up by Cloud Init and used. So the first and most important file that we need to look at that's part of this is this YAML file, which is used to configure the VM using Cloud Init. So let's go take a look at that file. So this is a cloud config YAML file with basically configuration information that tells Cloud Init how to configure the VM. So the first thing that I basically set up here basically tells Cloud Init to use the apt package manager on Ubuntu. Every Linux distro uses a different package manager. So Cloud Init works with multiple different Linux distros. So, you have to basically tell Cloud Init which package manager you're using. In this case, we're using apt. Okay. And then a little bit further down in here, you'll see I tell Cloud Init which packages I want to install. So there's a whole list of packages here that I want to install to do, to pre-install and pre-configure on this machine, right? Now, some of these packages are automatically included in Ubuntu. some aren't. So the ones that aren't, you have more work to do, and those are specifically the Azure CLI, PowerShell, and Terraform. Those three are not included in Ubuntu by default. So if I were to say, apt install Azure-CLI, apt would not know what I'm talking about. So I have to give it that configuration information. So I do that up here in this apt section. I add three new sources, one for the Azure CLI, which you can see here, okay? And this basically sets up the apt package manager to give it the ability to install the Azure CLI. And to do that, you need to include the GPG key for security reasons, right? So that's the current GPG key. If that GPG key changes, this will no longer work. So you'd have to go in here and update this YAML file to use the new GPG key. Okay, so that's the one that we use for the Azure CLI. Here's the one that we use for Terraform. And here's the one that we use for PowerShell. Okay. So once I have those set up, when I go to say install Azure CLI down here in the package section, apt actually knows where to go to get that done, and it has all the keys available to do it. All of these other packages we're installing basically to make it possible for us to domain join this machine to Active Directory domain services using a capability called WinBind that's part of Samba. And also to auto mount Azure Files shares using AutoFS. So AutoFS and CIFS utils are the ones that we're using for that. So other stuff that gets done in this YAML file, we automatically upgrade all the packages on the system. We automatically reboot the system if it's required. And we also create this file. This is a little esoteric. I'll just quickly tell you why this is here. In Ubuntu, there's a new utility called NetPlan that is used to configure the network. Cloud.init has adopted NetPlan, and it writes out a NetPlan configuration file that's used to configure the network. You have to modify that NetPlan configuration file in order to get DNS to work. And so what I'm doing here is I'm telling Cloud.init, please don't overwrite modifications to that file on subsequent reboots. Because if we didn't write this file to disable updates to that NetPlan configuration, the next time we rebooted the system, we would lose all of that custom DNS configuration that we add. So that's the reason for that. So if we go back to Jumpbox Linux, let's look at this second shell script. So this is a shell script that is going to actually domain join our machine and set up auto mounting of Azure files. So let's go have a look at that script. So this script gets pushed onto the VM using Cloud.init. I create a log file for debugging purposes that you can go look at here post execution. And so basically what we do is we I had a lot of challenges passing data to Cloud.init, and the easiest way for me to do that was to pass data to it using ARM tags. So if you go look in the portal, you will see, if I pull up that Jump Linux 1 virtual machine, a bunch of ARM tags have been created, and you may wonder why. So a few of them are ones that you're familiar with from previous configurations like cost center, project, environment. The rest of these, like the domain name, the DNS server, the storage account name, the storage share, those are all new and specific just to the VNet app configuration. And I'm creating these tags on the VM so that I can read them from inside the VM using the instance metadata service. So Let's see how that looks. So if you look at this, so the first thing I want to get is the name of the key vault where my secrets are stored. Well, Azure has an instance metadata service that allows a VM to ask questions about the environment that it's running in. Okay. And all that instance metadata is helpfully exposed to us by Cloud Init in this file here, instancedata.json. So all I have to do is go in and pull values from that instance data JSON to read values of ARM tags. Super handy. Okay, so here I go get the tag for the name of the key vault that I want to connect to, the name of the Active Directory domain services domain that I want to join, mysandbox.local, the IP address of the DNS server, the storage account where my Azure Files share is located, and the actual share name for my Azure Files share. Okay, and then once I have the key vault, I could do some fancy stuff here to actually connect to the key vault to go get my secrets. So to do this, I needed to enable a couple things. I digress here for a second. If we go back and look at this config file, you'll see for Jump Linux 1, I've created a system assigned managed identity, which can be used to grant privileges for this specific VM to authenticate with Azure with Microsoft Entra ID. So that it can then go do things, okay? So the first step in making this work was to create a system assigned managed identity. The second thing that was required is I had to create an access policy so that that managed identity was permitted the ability to get secrets from our key vault. So that's done here in our Terraform configuration. So those two things were done in advance. By the time this script runs. So getting back to our script, I can go get an authentication or an access token that I can use to authenticate from Key Vault using this code. Once I have that token, I can actually use that token to authenticate and get the values of secrets I want. Specifically, what the name of our admin user is going to be, bootstrap admin, as well as what the password is for that admin user. Those are both stored in Key Vault in a secure fashion. So this gets us away from storing secrets in configuration files. We have our secrets in one place. They're in Key Vault. We get them dynamically at config time using this code. Okay. Other stuff that we do in this script, we basically enable the ability to use SSH using passwords. By default, that's disabled. So I want to be able to do that. We've actually demonstrated that working right here. In VS Code, we were able to get a SSH connection to Jump Linux 1 using a password. So we know that's working. We are going to configure NTP, the NTP service that keeps the time synchronized between Jump Linux 1 and the domain controller ADDS1. Time synchronization is important. If that gets out of whack, synchronization of your credentials can get messed up. Here's where we update our hosts file to include the domain name that we're joining. And here's where we go in and we update that DNS configuration I was telling you about earlier. So you see this 50 cloudinit.yaml file. That's a file that's automatically created by Cloud Init at boot time. Okay, and it includes all kinds of things like a MAC address that you can't get any other time than at boot time. Okay, so it creates that file once, which is great, but then I want to make changes to it, right? Like add some custom name servers, add some custom search domains to my DNS search domains. I want to do all that stuff, and I need that to persist across reboots, right? So you'll remember where in that YAML file, I wrote this file out, this disable network config. that is going to ensure that those changes that I'm making in the script don't get overwritten in the next reboot. Okay. So these are the changes I'm making to, basically add a list of custom DNS server addresses and a list of custom search domains to my DNS search domains. Okay. And then I use this special Ubuntu NetPlan utility to generate a new network configuration, and then I apply that network configuration. Okay. And then I check it to make sure it took. So once that DNS configuration is set up, that enables connectivity to my domain controller, at which point I can domain join this machine. One last DNS piece of housekeeping. If I ever reboot this machine and it needs to renew its DHCP lease and I get a different IP address, I have to dynamically go update my A record in my DNS server. So this code does that. All right, now we're ready to domain join. I go in and I modify my Kerberos configuration and add the appropriate settings to domain join the machine. I'm going to use Winbind to do that, so I have to modify this Samba SMP conf file to use Winbind. Okay, and I reload that, and here's where I actually domain join the machine using Winbind. Okay, and if that succeeds, it should show up in our log file. So once I've domain joined the machine, I have to do some more configuration to Winbind. Specifically, I need to go and tell the name service on that Ubuntu machine to go look at Winbind when it's looking for users and groups. So that's where these changes take effect. And I also need to configure the pluggable authentication module to use Winbind when users are logging in, and also to automatically create new home directories for Active Directory users when they log on to the system. Okay. And then finally, I want to add my domain administrator to the list of administrators on my Ubuntu machine, a so-called sudoers list, right? So that they can do administrative functions. So all that is required to get the machine domain joined and to get my domain administrator account set up, bootstrap admin at mysandbox.local, which we've logged into during the smoke testing, so we know it works, and also to give it administrative privileges on this specific machine. Great, so the final stuff that we do is used to set up auto mounting of our Azure File Share. So we're going to use a service called AutoFS to do that. And that requires modifications to a couple of different config files. We're going to create this auto.fileshares file. And this is basically the one that tells it to go mount this particular Azure storage share using these options. And there's a bunch of options here. I'm not going to go through all of them. It took me forever to figure this out. But the key ones I'll point out are we're using Kerberos security here. And we're telling it that when we mount, go grab the user ID of the currently logged on user. And provided you've set up Winbind correctly, and provided that user has privileges against the Azure File Share, the mount should work, right? Which we've proved it does during the smoke testing. So I'm not going to tell you how long it took me to figure this out, but there it is. It works, and it works great. We're going to auto mount that directory at boot time. So once you've created that auto.fileshare file, you have to tell AutoFS to use it to do the auto mounting of file share. So that's what we do here. We basically overwrite auto.master and add our own configuration that points to our auto.fileshare configuration file. Once we restart AutoFS, we're good to go. Auto mounting or dynamic mounting of that file share will work. Dynamic mounting is required. You cannot static mount anything that requires Kerberos to authenticate, or your computer will not boot. I found that out the hard way. So that's it for our configuration script that gets run when we push our cloud init configuration data down to the machine. So we've gone over the YAML file here with the cloud config. We've gone over this script, which configures the VM. It adds it to Active Directory domain services using WinBind. It then creates an auto mount or a dynamic mount to Azure files. And then this last script simply goes in and adds the Azure PowerShell module so that we can use that locally if we need to. And that script is right here. It's pretty simple. I'll just go to the main section here, skip to the details. We basically just, in main, do the following. We set up NuGet as our preferred package provider, and we set up a policy that makes it trusted so that we can install stuff from NuGet. And then I go install the Azure PowerShell CM module if it isn't already installed. Okay, pretty straightforward stuff. So that basically covers the cloud init portion and the cloud config portion. So if we take a little bit deeper look at the configuration of Jump Linux 1, we've got a name, a resource group, a location, all those we pull from previous variables, from previous configurations that we've deployed. Here's our admin username, which we get from Key Vault. You can see here, I've tacked on the word local to it. So whatever name you choose when you run Bootstrap as your default administrative user, I'll just tack the word local on the end of that, and we create a separate local account that you can use to log into that machine. Here's where we, set up our NIC. We set up automatic patching, platform orchestrated patching. Here we set up a dependency on the VM extension for JumpWin1. Why are we doing that? It's because that VM extension is the thing that domain joins the Azure files and the Azure storage to our Active Directory domain services. So the scripts that I just walked you through wouldn't work unless this script had already been run. So I just go ahead and put a dependency in there to make sure that we don't get into any kind of weird timing issues, okay? Here's where I create all my tags and all those extra tags that I needed to configure the VM using the instance metadata service. You can see specified here. Here's where we configure our SSH key that we can use to log in using SSH, using a key to that local administrative account. We configure our operating system disk here. We configure our source image here. I already talked to you about the managed identity that we set up so that we can pull secrets from Key Vault from that machine. And here's where we pass the cloud config data down to the Linux jump box. Nothing special in the NIC configuration. That's pretty straightforward. I do wait to create the NIC until all the NSGs have been created. And here's the access policy that's required in order to allow this virtual machine to get secrets by name from Key Vault. So I only grant it the privileges that it needs, which is get. So you need to know the secret name in order to go get it from this VM. Yeah, that is pretty much what I intended to walk through from a documentation perspective on Jump Linux 1. I think we pretty much covered everything that is listed here. Let me just quick, this is pretty much everything that we covered in the video. So I hope that was useful for you, and we will see you in the next video. Thanks a lot, everybody.